Hello and welcome back. So today we're going to continue with proofs, but instead of doing them with algebra, we're going to do them with segments. So all the properties of equality that we already worked with still apply. So those are listed. And then we're going to look at properties of congruence. So the reflexive property of congruence for any segment AB is going to be congruent to AB. AB, and it's a segment, is congruent to AB. Symmetric property. So if segment AB is congruent to segment CD, then segment CD is congruent to segment AB. Okay, and then there's also a transitive property. So if AB is congruent to CD and CD is congruent to EF, then AB is congruent to EF. So it's just like if A equals B and B equals C, then A equals C. So definitions. Definition of congruence. Segments are congruent if and only if they have the same measure. So if AB is congruent to CD, then AB equals CD. And then same thing, going the opposite direction. If AB equals CD, then AB is congruent to CD. Definition of a midpoint. So a midpoint of a segment divides the segment into two equal parts. If M is the midpoint of AB, then that means AM equals MB. And then a postulate that we had last chapter. So if A, B, and C are collinear and B is between A and C, then AB plus BC equals AC. So this section here plus this section here equals the entire line. Okay, so then a little bit of practice with this. So I'll do this with you since a lot of these are new. So if PQ equals PQ, then PQ is congruent to PQ. So that is your definition of congruence. If K is between J and L, then JK plus KL equals JL. So that's that last one we just did, segment addition. EF is congruent to EF, so that is the reflexive property. And you can just say prop, and it's of congruence. If RS equals TU, then RS plus XY equals TU plus XY. So that is from the last section, that is substitution. You are substituting TU for RS. If AB equals DE, then DE is equal to AB. So that is the symmetric property. If Y is the midpoint of XZ, then XY equals YZ. That is your definition of a midpoint. If FG is congruent to HI and HI is congruent to JK, then FG is congruent to JK. So that is your transitive property. If AB plus CD equals EF plus CD, then AB is equal to EF. So that is your substitution property because you're substituting an equivalent value. If PQ plus RS equals TV and RS equals WX, then PQ plus WX is equal to TV. So this one is also going to be substitution property. Okay, number 10. If LP is equal to PN and LP and N are collinear, then P is the midpoint. So that's definition of a midpoint. If UV is congruent to UV, then UV is equal to UV. So that is your definition of congruence. If CD plus DE equals CE, then CD is equal to CE minus DE. So you are subtracting there, so that's your subtraction. And oops, one mistake, I'm sorry, number 8 should be subtraction. I accidentally said substitution, but I meant to put subtraction. So because on that one, they're subtracting CD on both sides, that's actually subtraction. Sorry about that. Okay, continuing on. So now we have some practice with segment proofs. So we're gonna go through and do this together. And I'm gonna leave just 2 of them for you to try on your own. So we'll do number 1, and then we'll do 4, 5, and 6. So those are a little bit more difficult, and I'll let you try 2 and 3 on your own. So number 1, they start off with the given statement, as they should. So we know E is the midpoint of DF. So that means we know DE has to be the same as EF, and that is by definition of midpoint. Okay, so then now they're saying DE plus DE equals DE plus EF. Well, so because we know that DE and EF are equivalent to each other, we can go through and add those to both sides since they are equivalent, and that would be by the addition property. Okay, so then we know that 2 times DE is equal to DE plus EF. And so they just combine to like terms on the left side. So we would just call that simplify. So anytime they're not changing what is on each side, they're just combining like terms, that's simplify. DE plus EF is equal to DF. So on that one, they are using the segment addition postulate. So they're saying this plus this equals the entire thing. So we'd say segment addition. And then on that last line, they're saying 2 times DE equals DF. So they can do that because if you look at line 4 and line 5, notice how 2DE and DF are equivalent to the same thing. So that would be substitution. Or you could also argue that that's transitive. Either one would work. So I'm going to put / transitive. Because you could look at it as if A equals B, B equals C, then A equals C. So that's also a possibility. But if this were an exam, I would take either substitution or transitive. So like I said, I'm going to have you try 2 and 3 by yourself, but we'll do the rest of these. So number 4 is K is the midpoint of JL. M is the midpoint of LN. So given for step 1. JK equals KL and LM equals MN. So that is by the definition of a midpoint. Then it says JK is equal to MN. Okay, so if JK is equal to MN, that's actually also given. So make sure you always check all your givens. So that's a given. So then they're saying, all right, MN is equal to KL and LM is equal to MN. So we need to think about what we could do there. So there's probably a couple options. So because we know JK is equal to MN, it looks like what they did is they replaced JK with MN here. So they just went, that's MN. And then here they said LM is equal to MN. So they left that the same. So all they did was they substituted MN for JK. So I would call that substitution. But I would take transitive as well. Then they said, okay, so now that means that I know LM is equal to KL. So on this one, let's think about the process. So we know MN is equal to KL. And we know that MN is also equal to LM by step 4. So therefore, LM has to be equal to KL. So because we're using these two statements here in line 4, this is going to be a case of a transitive because we've got an A equals B, B equals C, so A equals C. And that one's a little tricky, so you might want to reorder it if that helps you out. So you could say if KL equals MN and MN equals LM, then LM has to equal KL. Okay, so then they said, well, that means KL equals LM. So all they did was they reversed the order from step 5. So that's your symmetric property. And then they said, well, if they're equal, then they're congruent. That's definition of congruence. So as you can see, these get a little bit tough. I'm just going to put that congruent symbol there. But we'll do 2 more. So number 5, we've got xy is the same as uv, yz is the same as tu, and that's given. All right, so next up they said, okay, then that means xy equals uv and yz equals tu. So that's just our definition of congruence. If they're equal, they're congruent. So then they said, all right, well, that means I can say xy plus yz equals xz. So look at what they're doing there. They're just saying this plus this equals the whole thing. And then this plus this equals the entire thing. So that is segment addition. Okay, so then they said, well, uv plus yz equals xz. So let's analyze what they did there. So they replaced xy here in line 3. They replaced that with uv. And how they knew that is because they knew those are equivalent. Everything else they kept the same. Then here they replaced tu with yz. And they knew that because they knew those were equal to each other. And everything else is the same. So that would just be substituting. All right, so then they said that means xz is equal to tv. Well, why did they figure that out? Well, it's because this yz plus uv uv plus yz, that's the same thing. So that means this and this are equal to each other. So that one, I would take either transitive or substitution. I think you could argue either way. I'm just going to put slash transitive. Just depends as if you're looking at it as just one step or two steps. And then they said, all right, well, then that means those two are congruent. So because they're equal, they're congruent. That's definition of congruence. And notice how they made sure this statement matched exactly the proved part. Okay, last one. So we have YW is congruent to YZ. And XY is congruent to VY. So the first one's given. So then they just said if they're congruent, then they're equal. So that's definition of congruence. Okay. So then they said, all right, well, XY plus YZ equals XZ. So that is just showing segment addition. They're saying this plus this equals the whole line. Okay. Next they said VY plus YW equals VW. So same thing. They're just showing segment addition. Then they said, all right, VY plus YW is equal to VW. So let's look at that. So VY plus YW is equal to VW. Did I skip a line somewhere? I feel like I did. Okay, sorry. All right, so before I was looking at step 5 when I did that second segment addition. So segment addition goes with step 5. I accidentally skipped step 4. So let's go back to step 4. So on step 4, they said VY plus YW equals XZ. So let's think about why they said that. So we know that VY is equal to XY from this line. So they replaced the XY with the VY. And they were able to do that by substitution. Okay, so we also know that YZ is equal to WY or YW. So they also replaced there. So line 4 should actually be substitution. I just skipped a line for some reason. So just switch the order on 4 and 5. Sorry, that's so messy, but that's substitution. Okay, now we're back on track. So now we're looking at line 6. So now they're saying XZ is equal to VY. So why they're saying that is both of those things are equal to VY plus YW. So that is either, you could say transitive or substitution on that. Again, it depends if you're looking at it from one line or two lines. All right, and then lastly, they said, well, if they're equal, they're congruent. So that's definition of congruence. So hopefully you're starting to see that these pretty much all follow a similar pattern every time. Lots of substitution, lots of transitive, lots of definitions of congruence. So give 2 and 3 a shot. They're not as hard as the ones we just did. See if you can do them, and then check your answers. So eventually we're going to ask you to do these from scratch without the reasons written in, but we're going to work on slowly building you up to that. So that's it for section 2.6. Thank you. See you next time.